Hello and welcome back to Math 100. This is section 2.4, estimating the answer. So at the end of chapter 2, we have a couple of smaller sections, and 2.4, estimating the answer, and 2.5, very large and very small numbers. So let's get to it. This is a rather short section, and it's going to require just one video. All right, as usual, I will share my screen and we will get going on section 2.4. All right, so section 2.4 is on estimating the answer. We have previously talked about this, how you estimate or guess or combine the word guesstimate the answer. So basically, you just come up with a ballpark figure, like what do you think is the answer approximately? And this is going to help you very in a very practical sense, because in many situations, such as, a very simple situation like when you go shopping at grocery store, you would just sort of add up numbers, the prices of things you are buying, and if it's way off than what you were told at the checkout counter, then you question perhaps the cash register or whatever. So, this is something that you should keep in mind as we go through this section. All right, so the overall idea here for this section, basically there's only one, is that use rough estimates to get an approximate answer. Okay, so here is the first question. Let's say it takes 2 hours to fill a 20 foot by 40 foot, 14 foot pool, 20 by 14 foot pool. Then how many hours approximately, if everything else stays the same, would it take to fill a 40 by 30 pool? Now, this is of course much larger. So, you can sort of guess, first estimate the answer, and then find the answer using the techniques we learned in the previous section, namely the proportions. All right, now 20. Oh, so by the way, I'm assuming that the depth of the pools are the same, okay, because that's not given to us. So we have to assume certain things. 20 by 14. So how many square feet are we talking about? That is 280 square feet, right? And then how about 40 by 30? That's 1,200. Okay, now you don't have to come up with the exact ratio here. 280, that's close to 300, right? And then this is 4 times as big. So you know right away, just by looking at the square footage of the pools, that the larger pool is more than 4 times the size of the smaller pool, which we have just filled in 2 hours. So 2 times 4, okay, it's going to take you more than 8 hours. That is for sure, probably not much more than 4, because the ratio here is pretty close to 4 to 1, right? So my guess is maybe 9 hours, between 8 and 9 hours. And that's a ballpark figure. Now, of course, in reality, the precise answer may not be as accurate because, certain things change and certain conditions change. So maybe the ballpark figure is all you need. Now, let's practice, our precise calculations because we have done that before, and it is a great time to review this, right? So we could say about 4 times as long. Okay, that's the answer to the first part A of the question. And so therefore about 8 to 9 hours. Okay, that's the guess. Now, if the precise answer comes down to be like 2 seconds or 15 hours or whatever, okay, way out of that, then either the precise answer, the method we used, is incorrect, or maybe our guess is completely out of the ballpark. But we will see that. Okay, that shouldn't happen. All right, so we have 20 by 14. Okay, and then you can say this. Okay, so this is 20 feet by 14 feet in 2 hours, and that is equal to 40 by 30. And then we don't know what the number of hours, right? Okay, we can call it X if you like. You can call it whatever you want, okay? And so we already know the answers or the multiplication, the products for these top parts, which are called numerators. Numerator here is 280. And over here, it's 1200, right? So if you use cross multiplication, you can say 280 times x is equal to, and cross multiplying these, that's 1200 times 2, and that's 2400. So x, I don't want to use the language of algebra very much, but x is not too hard, right? That's just unknown, and you can call this anything you want. You can call this h, maybe for hours or whatever. So if you do this division, 2400 divided by 280, it comes down to be about 8.57. And of course, the units we're using here is hours, right? So we have 8.57 hours. Our estimate at the beginning was between 8 and 9 hours. So this is very much in within our estimated range. And so this is the correct answer. Okay. Now, again, the emphasis here is trying to figure out this part. This is the what we are focusing on. Okay. Can you estimate just by looking at how the comparing the sizes, the size of the pools? Can you figure out approximately how long it would take? And so this is the correct answer here. By the way, you could also do this, right? This is 140. 280 divided by 2 is 140. Okay, and so what does this number represent? Well, 280 is the number of square feet. Okay, and this is by the 2 hours, right? So it's really what we are saying is 140 is the number of square feet that this water system can fill per hour. Okay, so it's 140 square feet per hour. And so all you really had to do for this one is to divide 1200 square feet. Okay, that's this thing on the top by 140. And if you do that, you also get the same answer, right? So that is another way of finding this correct answer here. Now, sometimes an estimate is all you need, okay? This also helps you know when you make a calculation error, and then sometimes all you need is an estimate, right? So look at the second question. How much is 45 million plus $5 million? Sorry, 45 billion plus $5 million. Okay, so let's say your government is trying to work on some project, and it's a very expensive project, maybe like the national infrastructure reinforcing or something like that. Okay, so it's 45 billion, and then they find out, you know what, we need to add some more because things are costing more than expected. It's going to add $5 million to the original budget. You know what the answer is going to be here? Okay, now the precise answer is, of course, 45 billion and 5 million. That's about the only way to give you the precise answer. But what I want you to see is that this sum is approximately $45 billion. So what? Didn't you add 5 million? Yes, I did. But in light of how big this number is, 45 billion, 5 million is such a small number that it is almost negligible. Okay, it is almost like this. If I give you $1 million, and then if I decide to give you a penny more, how much is that? Well, it's about million. Well, of course, it's $1 million and a penny. Okay, but who cares about the penny, right? And in this sense, okay, I want you to realize how much smaller this 5 million is. Although $5 million is a significant amount of money, in light of or in the context of a big number like 45 billion, yeah, this is almost negligible. And so the answer here, which I would like you to give, is it's about $45 billion because the other amount, $5 million, is such a small number compared to the 45 billion that it is almost negligible. Okay, so that's the correct answer here. All right, yes. Now let's see one final example here. Sometimes it's hard to estimate the right answer. So it is sometimes surprising, and your estimate could be way off. And so here's an example for that. In how many ways can you arrange a starting lineup, including the designated hitter and the pitcher? So let's say you have a baseball team, looks like an American League team, because they allowed a designated hitter. Sorry, there should be a D at the end here, DH, right? So in the typical lineup, if you look at the box score or something of a baseball team in an American League, you have 10 starting players' names. Okay, so you have the first to hit, the first hitter, the second, they called it the 2-hole, and then you have the third, fourth, this is called the cleanup, and so on, right? So they have 9 hitters, and then you have the pitcher, right? Pitcher doesn't hit mostly in an American League team, and so you have 10 players to start the game. Let's say you already have 10 players. Okay, you have a group of 10 players, and then as a manager, you are going to have to put them in this particular order. Okay, so actually it's 9 and yeah. Okay, so 10 players. So in how many ways can you line up these 10 people? Basically, it's the idea. It is a question equivalent to the following. If you have 10 people, 10 children, and 10 seats, okay, in how many ways can you arrange? If you have 10 seats and 10 students or 10 children, in how many ways can you seat them? In how many different ways can you arrange for that? It is basically the question called permutations, right? So how many permutations are there for 10 objects if you have to line them up all in a single line? Okay, and the answer, of course, we will learn this later. Okay, so in chapter 4, we will be studying how to count these things. But the answer turns out to be, and here's pretty much the idea. There are 10 people to choose from for your first seat, right? Or, who is going to be the leadoff hitter? Well, any one of those 10 people, right? But then once you choose one of those 10 people, there are only 9 left for the second hitter, right? So then you multiply 9 by 10, and then you do 8, 7, because the number of available players, it decreases by 1 each time you place somebody in a spot. And so the answer is the product of all of these numbers from 10 down to 1. Okay, now we have a name for this. You don't have to know this right now. In chapter 4, we will revisit this, but it turns out to be 10 factorial. So that's the answer. Now I ask you to estimate this. You probably didn't know how to estimate it unless you have been familiar with permutations problem. Okay, so that is the answer, and it sort of makes sense. But what is surprising is that this is a ridiculously large number. Okay, can you guess what this is? If you multiply all the integers from 10 to 1, it turns out the answer is over 3.62 million. Wow, right? I mean, this is how many choices a manager has to list or to line up 10 players. Yeah, and that is over 3.62 million. And so sometimes it is even hard to estimate, to come up with a ballpark figure. Sorry, no pun intended here. It's ballpark figure to come up with a lineup of 10 starters. Okay, so it is sometimes difficult to estimate, but in many cases, such as in the grocery store, or such as when you are trying to compare the proportions, try to estimate your answers in order to avoid some ridiculously crazy answers which you may have come up with an error. And also just for for practical purposes, an estimation is a great tool. Okay, that's it for this short section. Now you have this one question that you can answer before you do your online quiz, which is pretty much the same question. And so you go ahead and do that. And that is the end of section 2.4. All right, I will see you for section 2.5. Have a wonderful day. Take care.